Good morning everyone. Today again we will continue our numerical. Okay, chapter 1. Chapter name is solution. So here first numerical is vapor pressure of pure liquid. A and B are 450 and 700 mmHg. Okay, it means you have taken the two liquid A and B and both will exert vapor pressure in pure state, which is represented by P naught A is equal to 450 mm. Okay, and P naught B, it is given 700 mm. Okay, this is the vapor pressure that they will exert in their pure state. Okay, at 350 Kelvin, there is no need of this 350 Kelvin because we are not using a temperature in the formula. Okay, find out the composition of liquid mixture if the total vapor pressure it is given here. What does it mean? If you have taken the two liquid in a mixture, then both will exert together 600 mmHg vapor pressure. Okay, you have to find out the composition. Composition means you have to calculate here mole fraction of A and mole fraction of B. Okay, so this you have to find out. Again, one more thing is given here that you have to find out the composition in vapor phase, means mole fraction you have to calculate in vapor phase also, and this is in liquid phase. Okay, that XA XB it is given here, this is given in liquid phase. In vapor phase you are representing with YA and YB. Okay, so before doing this numerical you should know the formula of calculation for the vapor pressure, and that is according to Raoult's law. Okay, so Raoult's law vapor formula it is given here. P total is equal to PA plus PB. Okay, what is PA PB here? It is the partial vapor pressure, okay, of A and partial vapor pressure of B. Okay, so partial vapor pressure, how you can solve? By using this formula XA into P naught A. Partial vapor pressure of B, you can calculate XB into P naught B. Okay, so total vapor pressure it is given to you, and mole fraction of A and B you have to solve. P naught A and P naught B, this is also given to you. Okay, so you can calculate the numerical. P total is equal to PA plus PB, and that is given to you. PA is equal to XA P naught A and PB is equal to XB P naught B. Okay, so you can open this formula, you can get this. Okay, but here one thing you have to take care, because mole fraction of A or B, how you can solve? Two different variables it is given here. Okay, but you can calculate only the one variable, so you have to know about the relation between XA and XB. By using that relation you can solve the numerical very easily. How you can make one variable only? By using both relation. XA plus XB is always equal to 1. So you can write now XA is equal to 1 minus XB. Okay, so here only single variable you can get. So XA it is given here, XB you can write 1 minus XA. Okay, 1 minus XA you can write, or XA you can write 1 minus XB, depends on you, whatever you want to put. Okay, any one you can use here. So by using this formula, now you have got the only one variable in that is XA. Okay, so you can see here P total is equal to XA P naught A plus 1 minus XA P naught B. XA you have to find out, every values it is given here. Total vapor pressure it is 600 mmHg. Okay, vapor pressure in pure state of B it is 700, this is given here. Okay, 450 minus 700 into XA. By using this you can solve the XA value, mole fraction of component A. So this is only the derivation that is given here. By using this formula you can derive this and you will get the answer. Okay, but you know now XB is equal to 1 minus XA. XB is equal to 1 minus XA. Okay, so if you have got the value of XA, you can solve the value of XB. This is the answer. Now in this next term it is asked composition in vapor phase also. So what is the formula for that? YA, this is the partial pressure in vapor state. how you can solve? It is equal to P naught A divided by P total. Okay, this, by using this formula you can solve this part also. Okay, so it is not a P naught A, it is only the PA. PA means partial pressure. Okay, so partial pressure you can solve here because you have solved the value of XA and XB. Partial pressure, I told you already, it is equal to mole fraction of A and P naught A. XA we have solved, P naught A value it is given to you, and you can get the value of partial pressure of component A. In the same way you can solve the partial pressure of component B. Okay, so YA if you want to solve, PA you have solved, that is 180, and P total it is already given to you. Okay, so you can solve the answer. And finally you will get the answer, that is 0.3. Clear? So next numerical, it is vapor pressure of pure water at 298 Kelvin is 23.8 mmHg. Again you can see here it is given for pure water. Okay, 50 gram of urea, NH2CONH2, this is the chemical formula, that act as a solute dissolved in 850 gram of water. Okay, how much quantity of water it is given? 850. Calculate the vapor pressure of water for this solution and its relative lowering. Okay, so what you have to solve here? Vapor pressure of water for this solution. For this solution it is given, it means you have to solve the value of PS. Okay, now for this you should know the formula. It means relative lowering it is asked. So what is the formula of relative lowering? RLVP, relative lowering in vapor pressure. P naught minus PS divided by P naught is equal to X2. Okay, this is the formula. And P naught, what is there? It is the vapor pressure in pure state. PS you have to solve. P naught again it is given. What is X2? Mole fraction of the solute. Amount of water it is given, and amount of water it is given to you, that is 850 gram, and amount of urea also it is given, that is 50 gram. Okay, so you can solve very easily X2. Okay, so now you can see here P naught minus PS by P naught is equal to X2, and X2 is equal to N2 by N1 plus N2. Again you know N2 is equal to given mass by molar mass. Okay, so everything it is given to you. Given mass of urea it is given 50 gram. Okay, molar mass of urea you can solve, that we have solved here. Okay, and given mass of water it is given to you 850 gram, and molar mass of water also we know very well, it is how much? How you are solving this? H2O, 2 plus 16, it is equal to 18. Okay, so everything you are having, and you can solve the numerical. How you can solve the molar mass of urea? NH2CO NH2, this is given to you na. Of nitrogen what you are using? 14, it is the molar mass, and for hydrogen you will use 2, for carbon it is 12, for oxygen it is 16, plus for nitrogen it is 14 plus 2. So this is the molar mass of urea. Okay, that you can put here in the value of M2. Okay, molar mass of urea. After calculation you will get the value, that is 50 gram. So every value it is given to you. So by this way you can solve PS. Okay, P naught given, PS you have to solve. X2 we have solved by using this. So final answer you will get PS is equal to 23.4 mmHg. So next numerical, it is the boiling point of water at 750 mmHg, it is 99.63 degrees Celsius. Okay, you have to take care what value it is given here. This is the boiling point of water. Okay, means of solvent it is taken here. How much sucrose it is added, it means W2 you have to solve. How much quantity of sucrose it is added in water, that you have to solve. So how much quantity of water it is given? 500 gram of water, such that it boils at 100 degrees Celsius. It means after addition of sucrose in water, you have got the solution. And for solution, what is the boiling point here? It is 100 degree Celsius. So you have to use the formula for elevation in boiling point, because term boiling it is given to you. So you have to use the formula elevation in boiling point. So what is the formula? Delta TB is equal to KB into M. Okay, this is the formula. So delta TB it is TS minus T naught is equal to KB, and molality it is given to you, and molality is equal to moles of the solute divided by given mass of solvent. Okay, into 1000 you will do if it is given in gram. So this is the formula. Every value it is given to you. Okay, so what is the value of TS? It is the boiling point of solution, that is given to you 100 degrees Celsius. T naught it is for pure water, that is given to you 99.63. Okay, and KB value for water, actually it is giving in exam in numerical. If it is not given, then you should know its value is 0.52. KB is equal to 0.52. Okay, you can put here moles of solute. How you can solve? Moles of solute N2 you have to solve here. Okay, W1 it is given to you 500 gram. Okay, so every value you have got, you can get the value of N2. After calculation of N2, when you will get the value of N2, you can use this formula given mass by molar mass. By using this given mass, you can calculate, that is N2 into molar mass. Okay, molar N2 you have solved by that formula. Okay, molar mass you know you have to use for the solute. Okay, what is the molar mass of solute that you have to use? It is given to you sucrose. Okay, you should know the formula of sucrose, then you can solve the molar mass also. Okay, so molar mass after calculation you will get 342 gram. Okay, actually what is the formula of sucrose? C12H22O11. Okay, so by using this you can solve the molar mass. After calculation you will get 342 gram per mole. So our next numerical it is calculate the mass of ascorbic acid. Okay, it is vitamin C, and they have given to you the formula also, chemical formula, that is dissolved in 75 gram of acetic acid. It means it acts as a solvent. Lower its melting point by 1.5 degrees Celsius. Lower its melting point. It means they have given to you delta TB. Okay, and that is 1.5 degree Celsius. They have given to you KB for that. KF 3.9 kilogram per mole. Okay, they have given its lower its melting point, not boiling point, so it is delta TF. Okay, so what you have to solve here? Calculate the mass of ascorbic acid. It means amount of ascorbic acid that has dissolved. It means you have to solve the W2. Okay, so again you have to use the formula for lowering in freezing point. Okay, and what is the formula? Delta TF is equal to KB into M. What is delta TF here? T naught minus TS is equal to KB into M. And what is M here? Moles of solute divided by W1 into 1000. Okay, we have already done numericals related to this formula, but that we have done for elevation in boiling point. It is the similar only. Sorry, here KF will come because we are talking about the freezing point. Freezing point and melting point both considered to be same here. Okay, so you can see here every value it is given. You can solve very easily. T naught value it is given to you. Okay, so actually first you have to look here in which it has dissolved. It has dissolved in acetic acid. Okay. Yes, they have given to you lower its melting point by 1.5 degrees Celsius. Actually no need of use of this. Directly they have given the value, this only delta TF. Okay, KF value it is also given. N2 you have to solve. W1 it is given to you 75 gram. After calculation you will get the value of N2. Okay, then given mass by molar mass. What you have to solve? Given mass. So given mass is equal to N2 into molar mass. Okay, so this molar mass of which you will use, it is of solute, that is C6H8O6. Okay, so after calculation you will get the value of molar mass of acetic acid, that is 176 gram. Okay, so by using this formula you will get the final answer 5.077 gram, this value. Okay, so our next numerical it is calculate the osmotic pressure in Pascal exerted by solution prepared by dissolving 1 gram of polymer of molar mass 185,000 in 450 ml of water at 37 degrees Celsius. So what you have to solve here, osmotic pressure, that is represented by pi, which is equal to CRT. C it is concentration here. So in which form you have to take here? It is in the form of molarity. It's not a molality. In elevation and lowering we have done molality, but here it is molarity. Okay, into R. R what is here? This value you should know in Pascal. It is given to you 8.314 into 10 to the power 3 Pascal. Okay, if they are not given you have to learn. Okay, and this is molarity. R value you should know, and T, this you have to take in Kelvin only. Okay, so add 273 in that. Okay, you will get the value of temperature also. Okay, so first look here, molarity, how you can solve this molarity. What is the formula of molarity? Molarity is equal to moles of the solute divided by volume of solution into 1000. Okay, so moles of solute, how you can solve? How much quantity of polymer given? 1 gram. So 1 gram divided by its molar mass. Okay, so molar mass you have to solve. Prepare dissolving the molar mass. Okay, no need to solve, it is given to you. 8 molar mass 8,185,000. Okay, this is given to you. So by this value you can get the N2, and how much volume? 450. So by using this values you have got the value of molarity. Okay, so pi is equal to MRT. Molarity you can solve. R, this value 8.314 into 10 to the power 3 Pascal. T, temperature, it is given to you. So by using this formula you have got the value 30.96. Okay, Pascal. So you have to do numerical up to this only. Thank you and have a nice day.